Tennis, also known as ping pong, like any other sport, contains physics, and those who learn to manipulate it will give them the desired effect. What we will be discussing with you are some aspects that affect the motion of the ball.
It can be made of different materials such as sponge or rubber. If the material is hard, then less energy will be lost upon return, therefore retaining much of the speed, whereas softer materials will absorb more energy, so the speed is decreased even further.
Different sizes for the ball, such as the 38mm and 44mm, but the one commonly used is the 40mm, which weighs 2.7 grams. With the larger balls, they have more air resistance or drag. However, since they are also slightly heavier, they do not have as much deceleration.
While spinning as it is traveling through the air, the Magnus force will come into play. What happens is that the air will move differently because of the spin of the ball. The air is going towards the ball in the opposite direction that it travels. As the ball spins, either the top side or the bottom side will be spinning with the direction of the air. In this case, it's the bottom side. This will allow the air to go much quicker on that side of the ball. On the other side, it will be going in the opposite direction of the air, so it will slow the air down and make a vacuum of sorts. So because of this, the ball will go towards the side with the vacuum. So in this case, the ball will go higher.
With the Magnus effect, it'll be easier to predict where the ball will go, depending on its spin. If it has a top spin, the spin underneath the ball is against the direction of the air. So a vacuum will be present underneath the ball, causing it to go down. With a backspin, the lower airspeed will be situated above the ball, so it will move upwards. Spin will place the vacuum on the sides of the ball, causing it to curve. So if the vacuum is on the right side, it will cause it to go to the right, and then if it's on the left, it will curve to the left.
Apply mathematics to better understand the speed and acceleration of the ball. The first equation is power equals work over time. The more work you do in a smaller amount of time, the more power is distributed among less time. The second equation is work equals force times displacement. The more force you apply, the more work is put in certain distances. The third equation is force equals mass times acceleration. More force is present when a heavier object is being moved, even more so when its acceleration is faster. And finally, the last equation, acceleration equals final velocity minus initial velocity over time.